Hi everybody. In this set of videos, part 1 and 2, we're going to talk about alternate methods of multiplication and division. In this video, part 1, we're going to talk about partial products multiplication and the lattice method, both alternate methods of multiplication. This first method, partial products multiplication, is a great method to start off with your elementary school students. In this example, I'm going to show you how to multiply 253, a 3-digit number, by 6, a 1-digit number, using partial products multiplication. We start by breaking up the 253, very similar to what we did in partial sums addition. So 253 can be broken up by each digit, the hundreds place, the tens place, and the ones place. So we break it up into 200 plus 50 plus 3. We then multiply each of these partial sums by 6. So 6 times the 3, 6 times the 50, and 6 times the 200. This gives us 6 times 3 is 18, 6 times 50 is 300, and 6 times the 200 is 1,200. Which adds up to 1,518, our answer. This is very similar to the shorter algorithm we do, but the shorter algorithm we add at the same time as we multiply. So listen to how you do it. I bet you remember sort of how to do this or totally how to do this. You do 6 times 3 is 18, put down the 8, carry the 1. Then you have to remember that 1 up there. 5 times 6 is 30, plus the 1 is 31. So you put down the 1 and carry the 3 of the 30. Then 2 times 6 is 12, plus that 3 that we had up there. You have to either write it down or imagine it. Gives us 15. So that's the same as what I did here, but I added by carrying at the same time, which is a lot harder for young students to remember, and the place values are not emphasized in the same way. Both methods use the distributive property, so we're taking the 6 and distributing it, 6 times 200, 6 times 50, and 6 times 3 to each of those numbers. It's very similar to algebra when we multiply a polynomial by 6. So if we had 2x squared plus 5x plus 3 times 6, we'd do the 6 times the 2x, 12x squared. 6 times 2x squared, which is 12x squared. 6 times 5x, which is 30x. And 6 times the 3, which is 18. It's the same idea. And notice how similar our two answers are. We can do double-digit multiplication in the same way. So here we have a 2-digit number, 76, and our 3-digit number, and we're going to this time break up both numbers. So think of how you break up 253, 253, and then 76, 70 plus 6. Now we multiply the 70 times each number, and here are our results. Then we multiply the 6 times each number, and here are our results, and we add the results together. If you write it horizontally, it's a lot easier to keep track of. So let me show you this way. 6 times the 3, 18. 6 times the 50, 300. 6 times the 200 here. 70 times each, 70 times 3, 210. 70 times the 50 here, and 70 times the 200 here, and then you add them all up, going down. Much, much easier, and also much more similar to our standard algorithm, which is here. Notice how I moved the 210 over one place, just as here you put a 0 to move this line over one place. This makes us line up similar place values as we go. This is The binomial multiplication is very similar to this. So if you remember your algebra a little bit, if you look at 2x plus 3 times 4x plus 1, do you remember how you have to multiply each thing times each thing? A lot of algebra teachers call this the FOIL method, first, outer, inner, last. I don't call it that. I prefer to think of each term times each term, which is how you teach it when you teach multiplication to your students. And again, they both look very similar, and the terms, if you move over one, like I showed you before, will line up. The like terms will line up. Notice that the numbers in the left-hand problem are very similar to the ones on the right, the terms on the right. If you substitute x equals 10 in here, you get 2 times 10, that's 20, plus 3, just like here, 20 plus 3, or 23. And if you put 10 in here, you get 4 times 10, 40, plus 1. So these are the same numbers, essentially, if we let x equal 10. So now I'd like you to try it and pause the video for a minute and try this 3-digit multiplication here times this is 3 terms, and here's our 3 digits, and here's our 2 terms and our 2 digits. Try these two side by side, pause the video, and wait. Really try to do it on your own, taking the 532 and splitting it up, and the 42, and try multiplying each part times each part to make sure you can do it, both using algebra and with the numbers. When you're done, advance the video to the next slide where you'll see the answer. Let's see, did you get each of these terms right? Remember that they should be very similar looking at the end, same kind of structure, similar kinds of answers. And notice how I moved over one here in the second line so that I would get like terms to line up so that I could add them. Next, I'm going to show you something called the lattice method. If you're still shaking your head about the previous method, pause the video, go back a little bit, and look at that again. But if you're ready for the lattice method, here we go. So the lattice method has been used in many cultures. It's now used in some elementary schools as well as an alternative to the standard method of multiplication. So here's your example. We're going to multiply 381 by 54 using this method called the lattice method. We begin with a 3 by 2 grid. That's because this has 3 digits and this has 2 digits. That's why 3 by 2 grid. Here's our 3 by 2 grid. And then what we're going to do is draw diagonals in each square. So here's a diagonal, 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 and diagonal. Now take a look at the first answer that I've placed here. So where do you think this 1, 5 came from? Look at the 3, look at the 5, and think of this as the number 15. And I bet you could figure out what's going to go in the next couple spots here and here. Think about it for a second. Pause the video if you have to. See if you could fill in even the rest of the boxes before I do. So here's the next one. Did you get this one right? If you didn't pause the video, pause it now and see if you can do the other boxes. This is 8 times 5, which is 40. The next one is 1 times 5, which is 5, but we put 0, 5, just to keep something in that spot. And then the next row is going to be 3 times 4 is 12. Then 8 times 4, which is 32. And then 1 times 4, which is 0, 4. Add along the diagonals, carrying to the next diagonal as needed. What I mean by this is our first diagonal. There's only one number, just 4. This is our next diagonal, 5 plus 0 plus 2, which is 7. Here's our next diagonal, 2 plus 3, which is 5. Here, 1 and 5, that's 6 plus 4 is 10. So we put down 0 and carry the 1 to up in the next diagonal and get a 2 there. And that gives us our answer, 20,574. The lattice method, like partial products multiplication, does not require students to multiply and add at the same time, the way the standard algorithm does, right? So if you notice back here, we added along the diagonals after we were done with all of our multiplying. It may be easier for some students because it organizes all the multiplication. On the other hand, it doesn't have a connection to the base 10 reasoning behind it. Some schools argue that it's better for learning disabled students, but it really depends on a student's learning disability and what feels like it gets jumbled up for the student and what doesn't. So just keep that in mind. My son, who does not have a learning disability, loves the lattice method and still uses it to multiply. And he's 19 now. He still prefers this method. So it's really up to what works best for you.